Hello, I'm back with my 180 series scopes with a new set of plugins. So, previous episodes we had done the original ones, which I actually do prefer, the 50 megahertz ones with the buttons that are easy to operate. But technology marches on, and this is the next generation, and they go to 100 megahertz, and that's usually the set that's in my other 180C, which I want to use for an upcoming experiment, and they are flaky, except of course now that I turn a camera on it works. So. Hello, if you follow the channel, you know that I already had a run-in with an abandoned HP 182 scope with 1,000,000 faults in it. That left me stirred and shaken, but had a happy ending. Once we were done with the mainframe, we went on to repair the two 50 MHz plugins. This also turned into quite an adventure and a masterclass in analog electronics design, but we emerged victorious again. As we previously explained, the 182 is part of the early 1970s series of HP 180 transistorized scopes, which are downright amazing and pull way above their weight and age. They represent a high point in HP's Oscilloscope offering and are still remarkable to this day. Of course, the 182 is not the only one I own from the series. I also have a 180C and a rack version 180D that you might have spied in previous episodes. My 180C came equipped with the next generation plugins going up to 100 MHz. It worked well enough from the get-go, so I had not done anything besides cleaning it. However, it exhibits a bunch of intermittent issues. The brightness goes in and out, the triggering is unreliable, and the traces sometimes wobble up and down unpredictably. Plus, I never recalibrated the plugins. So let's take advantage that I have the now well-calibrated 182 frame with the bottom opened up, slide the 100 MHz plugins in there, and see if we can return both of them to perfection. Will we get more excitement than we bargained for once again? You bet. What I had problem with is triggering, but now trigger works by some miracle. I also had a problem on the other scope where the intensity would come in and out, and I thought it was the frame, it was the tube, but no, because when I put those plugins in this scope, it does the same thing. So that leads me to believe it's a gate control issue. The plugins has control of the intensity of the screen because it has to turn it off during the retrace. And then I had a problem with the delay trigger. Now it's triggering, so gee, so which tells me it's probably there you go. I can't trigger anymore on and it did, so it's all messed up. Okay, it lost trigger. It's just the delay trigger that's not working. It worked for a while. Okay, so it's definitely this. What the heck's happening? It looks to me like I should clean the switches. Yeah, those switches are known for causing trouble, and then I see the instead of wafer switches, they have put stuff that's directly printed on the PCB. Those are known to age very poorly and be very unreliable. Well, that's still how your multimeter is done today, but not anywhere as good as a good and expensive wafer switch. Okay, this is very loose, so I'm not the first one in there either. You can't remove the boards with the rotation switch unless you remove the shaft in the middle. However, in the manual it says that all you have to do is put it on 1 second in the main knob and 20 microseconds in the delay knob, and then pull the shaft. Oh yeah, that does work. Very gunky. There we go. Then they say pull boards out. Ooh. application this way. This was super sticky. Oh my. I put an I for inside and an O for outside. Get the spring out. Very sticky, all this. I push it through. Okay. And ooh, so here might be part of our problem. And it's not any better over here. Well, that might be an easy repair if that's all that's wrong with it. Okay, so I need a scraper. Okay. I'm pretty sure the grease was well-meaning, but it didn't age well. Okay, I usually don't like to use acetone because it's such a strong solvent. But here, I think. Ah! It's all over the place on the contacts too. Dioxide gold. Just on the contact themselves. Dielectric grease. And rinse and repeat with the other assembly. This is back. This is front. Same as before. Push the spring out. And rip. Oh, this one comes out. Oh, a lot easier. Oh, that was the spring. Yeah, this one is nowhere as bad with grease. Manual says put grease, so like this. I suppose this one would like that. Okay, in the meantime, before I put this back in, I want to do those switches from hell. Alright, and now the switches from hell, very easy to make it worse than you start with. Our favorite switches, we have been had by those switches before. Okay, this goes in here. This, oh, it's interesting. That's how it goes. All right. So you remove that. Oh. Okay, so they're not held by anything. Those are very deep ones. Okay. So the difficulty is not to lose the contacts. Share spring loaded. Okay, it's only 3s, so they are easily lost. Those little things, they are on springs, and then when you push them to clean them, they just fly all over. Well, actually, I'll put the camera on a wider field of view, so maybe when they spring I can trace them. So far, I have always recovered the one I lose. The important thing is to be off off the bench. The one you lose are the one at the other, on the other side that you don't watch. Okay. Okay, not lost any so far. Are those gold ones? Nope, not gold ones. So we'll use this version of the offset. Okay. Make sure to put it back in the right orientation so I can put the clicky in. Okay, we didn't lose anything. Hallelujah. Okay. You just take one bad move and then you're hosed because you've lost the contact. Okay. Isopropanol off the bench. Ah, there you go. I lost one, but I have the spring and I saw where it went. Alright. Hold on a minute while I find my contact again.
A little longer than a few minutes later.
Okay, found it. And now I have to put it back without losing it again or without dislodging another one. I'll use that in my right-handed position. If I get okay, put it back in without taking the other ones out and go back to cleaning. And then we do the same with the offset. We cautiously remount. And put the clicky back in. Alright, and then these were the easy ones. Now I have to do the ones at the bottom. That's going to be way more difficult. I think I want to take the front panel out, but it looks like the front panel is tied by the two inputs. So the soldering we do. Ground wire over here. And ground wire over there. Let's see. Oh yeah, that helps. Oh yes. So interestingly, these are different switches. And the one at the bottom are back to the ones we just cleaned. And I think I have more trouble with these than with these. These seem to work well. I'll probably leave them alone and concentrate on the one at the bottom here.
Later.
I cleaned all those switches, and at the bottom there's another series of switches, but it's the different kind. Hopefully you won't have a problem with these. I don't know how to open them up and they seem better protected. Right, so we'll put it back together. I'm not sure I've repaired anything, but at least that would be out. The bad contacts should be out of the way. What? I have 3 rows to do at the same time? Yes, I do. And top row. Okay. Alright, alright. Ooh. Did I mess that up? Oh no. I have to redo it again. Oh no. Okay. I managed. Okay, this goes this way. Woo! Turns way better. That should do it. Alright, and while you were not looking, I found 3 electrolytics in this card and I measured them all. And they were absolutely perfect, so I replaced them. Just because I had the exact good ones, and you never know where I was at. I also reseated all the ICs, so let's try it. Alright, have we done anything by just cleaning stuff? We still have the same problem. So we made it worse. Great. Fantastic. Oh, it's that switch over here. Okay, at least we know it's here now. It's this. Could be the switch that we clean and then the grease is interfering, although it didn't do anything on the other one. Or could be a contact in the socket of the card, and then twiddling this just moves the card. Okay, it would be nice to know which signal could cause that. One more observation as I was looking at the schematics. There are 2 modes for the delay. There is delay after triggering, and it could be that the trigger fails. Let's make it fail somehow. Well, now we can't anymore. There you go, it fails. Or there is start after fixed delay, and it doesn't work either. So it's not the triggering thing that does it as I thought. It's independent of that. It's just that the delayed time base doesn't start. Ooh, and there's a full bunch of things that make that thing start or not start. Alright, I found a good candidate for this fault related to a contact on board A4, this one, which is the switch. Those switches all the time delays, so it's either resistors or capacitors, a combination of both. But over here there's the on-off switch, and if this one is not making a good contact, it's just going to turn it off, which is what's happening. So it could be this wiper or the connection to the main board for this wiper. So let's look at signal 69. What is that guy? Usually tell you it's delayed enable voltage. Yes, so this is going to enable or disable the delayed time base. So, okay, so it looks like this is the one we should check if we want to do more of an engineering debug rather than poking in the dark. We should check the signal 69. So 69 it's board A4 on schematic 7 that we were looking at. Then goes to board A5, then goes to board A1, then goes to board A9, which is way at the back. So our signal is from that board, goes through this board, goes through A1, goes to A9, which is at the back. At A9, all it does is it grounds the comparator that starts the delay time base. So if we hook ourselves here, it's at plus 15 when it doesn't work, it's at 0 volts when it does work, then we know it's somewhere on that line that we have the problem and we can debug it more intelligently. So I have to find R21 on board A9, which is actually the one I recapped, so I'm sort of familiar with it. So we want connection between R21 and R19. That's here, R21, R19, that's where we need to measure. Okay, actually it was buried way down there, but I think it comes out on pin 1 if I read the schematics correctly here. It is a little one right here. And if I look at the board, I think I can see the trace going right to pin 1. So which tells me pin 1 is at the back. Or so I think. Alright, so test of the fault theory here. Okay, so right now it's working, it's at ground. Let's put it, yeah. It does not working and it went up to 15 volts. That's our fault. And yeah, okay, so you see a complete direct correlation. Okay, so that's much better. We have left the poking around here. We have traced an actual fault. And now we have to find where in the long chain we lose it. It's either the contactor of this board to A1 or we need to figure out if the wiper has a problem on that one. So now of course we're much better at this because we've been there once. We know how to do the Heimlich maneuver. Alright, and now we can be a lot more targeted. It's on pin 6. That is 1 and that goes to 6 must be this one. Oh! I see it. It's a bad solder joint right here. Let me look at it under the microscope, but my guess is that it's this solder joint. Okay, on the microscope it doesn't look half as bad as solder in the cup. I appear to have good contact. So no, that's not this. Huh. So the next culprit could be that contact here. And I see it's pretty wide open. So we're going to get that one close a little bit more. Right. Let's contact 1. Maybe they're all a little tired. Okay, not the first time we would have been had by a green connector. Okay, so let's put this one way back without having done anything to clean the contacts any further. I think they're good. And now we need to measure between here and here and see if we have any problems anymore. Off, on, okay, and the readings are all below 1 ohm, and off. Okay, I think we have repaired it. It was in the connector pincer right here, but not in the rotating thingy as I thought. So see, reading a schematics and being a bit more inquisitive just helps to ferret the actual fault. I also retightened those connectors, also they looked much better. Alright, put it all back together and try it again. Try again. And try again. Is the thing plugged in? Cigar, no cigar. Oh. Alright. What happened here? There you go. Oh, we have another fault now, which I had noted before, which is the instability. Well, I hope this is not another delay line problem. Trace unstable. Is it? Let's try the B trace. But we seem to have repaired the. Okay, so we need. We have repaired the. Yeah, that was the problem. So it looked like it was cleaning this that would solve the problem, but no, it was a connector. Okay, so the triggering is repaired. We got a moment of instability in height. Actually, let's go switch back to A. I might have to go through all the contacts of this unit too. So that's the bane of this style of units, is that the switches are so bad. Alright, so all I need to do is calibrate it, and then we have one more set of plugins that work. And I can already tell it's completely off by a good 20% here. This one. Do you do anything on this setting? Yes, you do. Okay. So what I have to do is 1 microsecond, 0.1 microsecond. I'm at the wrong, there we go, 0.1 microsecond. 10 megahertz, 10 nanosecond, there we go, we have pulses. And then there we go. Okay. And I see I need to adjust the horizontal. It's ringing like crazy. So we went from 20% off to smack on the dot. And by the way, where I was testing, I also found the source of my varying intensity beam problem is this little coax cable, which takes the gate output from here, from board A1, to over here, which is the back connector. And somehow those lugs don't make good contact, or the coax to the lug is not good. And you can tell the copper is all kind of dull, and I don't think it's coated with anything. So we'll deox it. I did a solder joint over the crimp joint, if that's where the problem was. I now have contact. We'll try it in the thing and wiggle it. And if it's good while I wiggle it, which it wasn't before, then we are golden. And now see if we have the intensity problem when I wiggle this one. No more. No more. And when I wiggle this one, no more. Okay, that was the problem. Alright, done with calibrating this unit. I might calibrate this one and then be done with it. After cleaning the switches and calibrating the vertical amplifier. And voila, it's all calibrated. It's a lot of adjustments. You have to do the attenuators and then a whole bunch of adjustments for RF. This was very, very far out of adjustment. It was very poorly compensated, but it all works. It's all perfect. So it's going to get the calibrated seal of approval. So here we go. CuriousMarc seal of approval. It says ignore seal to improve calibration, right? So these are part of my sheets that encourage you to repair your own instrument and get at the electrical parts inside. And the plugins have been returned to their original instrument, my 180C. It used to be all not syncing properly and wiggly, and it's just rock steady now. This has the scale flooding that you can flood the whole screen to take pictures, which I'll do soon. The extra speed mode, the delayed sweep used not to work. Now it's just perfect, and that's my favorite display here, where you can unfurl your waveforms. And that's all I wanted to do with these plugins, and I want to make, the reason I repaired them is I want to make some other fun experiments with this particular scope. So we'll see you then.